This video is going to cover replacing the battery pack in a Quantum Turbo SC flash battery. This unit uses 9.6 volts in the configuration of, I believe, 8 NiMH nickel metal hydride cells that are of the AA size, and then it has circuitry DC to DC and then high voltage oscillator to bring it up back to DC of several hundred volts, maybe 400 volts, so you can power a flash. So it sort of mimics the flash's own circuitry and lowers the recycle time considerably. These things are a big improvement over the old days where you'd have an ever-ready 400 or 500 volt DC disposable battery that you'd have in a battery pack. These old ones, the Quantums, did use the lead acid battery. It was 8 volt sealed lead acid, very easy to replace. Sometimes they have a little glue in there. You need a putty knife to pry the battery out, and then it'll drop out. But you know, the nominal voltage is 8.4 volts, so it's the equivalent of 7 AA NiMH cells. But if you put NiMH ones in here, you can do that, but the charging won't be right. The NiMH will get shortened lifespan if you leave it plugged in, so you'd have to manually unplug them, or you'd dramatically lower the life of your NiMH cell. So best to replace these just with a sealed lead acid. Quantum Turbo SC units are often found for about $50 on eBay. In fact, there's a fella on eBay who, for I think a pretty reasonably good price of $60, you send him your unit, and then he will do all the rebuilding for you and test it. And it looks like he also charges free shipping. So you ship it to him, he ships it back to you free, and the whole thing is 60 bucks. It's going to cost you about $25 worth of parts anyway. So if you don't like working with a soldering gun, this is a very attractive option, is this fella who's online over here. I contacted the parent company of Quantum, ProMark International, and they do offer a repair service. They say they will replace the battery at $195 with return shipping included. So that's another option if you want to have the factory do it. So I'm going to show you now how to do it yourself. The NiMH nickel metal hydride batteries have a nominal voltage of 1.2 volts. And so you're going to need, what, 2, 4, 6, 8 cells to get up to the 9.6 volts that the battery pack needs. I decided to get these ones that are already pre-welded in pairs. They're made by Kastar. The ones you want are the ones that are over 2 amp hours. The original ones were 2 amp hours. This is 2200 milliamp hours, so it's just a little bit more. Don't get the ones that are pre-wired and shrink wrap. They're a little bit cheaper, but they're only 1600 milliamp hours, and you're going to have more cleanup work doing some of these splices and stuff. Better to have the lugs so you can just do your own soldering. These are already joined with tack welds across here as a bridge, so these are ready to go as 2.4 volt cells that you're going to gang together in the same configuration that you have with your original batteries. So you're going to trace the old original batteries as they are bridged. This is a view from the top, or if on the non-bridged side, which is the one with the lugs, this is the as viewed from the bottom of the battery. So you'll put these all together, gang them up, line them up on their places, and then just put a little bit of glue in here, and we'll glue them together, and then we can wire them up. Again, this is the brand and model number of the Kastar batteries you're looking for. They're commonly used in Norelco shavers and Eltron units, and the number is AA2.4V-2200M-solder. And I neglected to say they cost $4.50 per pair post-paid, and since you need 5 sets of them, that's $18. But to get that price I had to buy 6 sets actually. If you buy just 4 sets, it's going to run you about 20 bucks. These other guys are a little bit cheaper, but you get what you pay for. They're not quite as good as these ones that have the lugs on them. The turbo battery has 8 screws, 4 on the front and 4 on the back. These 2 are smaller ones that attach this clip, but I think you need to take those off too. I think there's a bracket in there that holds the circuitry together. So let's unscrew all these and then we'll see what's inside. Well, I guess my memory is faulty because it looks like all the screws are the same size, all 8 of them. Anyway, no matter. When you open this up, all the componentry is on the top, facing the top of the unit, and the back of the unit has the circuit board, is the circuit board side. And there's a couple of shock mounts, and there is that standoff over here for the bracketry for the to hold the front on, and the back bracket attaches to the back bracket over here. So you can see they have the battery and they've wrapped it in a little bit of cushioning, and it has a proprietary little multi-pin connector. It looks like 6 pins going into this connector over here. We're going to reuse that, and they've got a couple of things going on here. You're going to see that there's 2 red ones, 2 black ones. They are all the same. The 2 black ones are the negative, the 2 red ones are positive. It's just a redundancy for carrying more current. And the other 2 are a thermal cutout and a variable heat resistor that changes the charge rate based on how warm the batteries are. And one is a battery complete cutout if the batteries get too hot. So let's open this up. So you'll see, so it will fit in the case. They've put them in sort of an offset staggered format, so they're not just 2 side by side. And they've been daisy chained together, so you have the 9.6 volts. And also they've been shrink wrapped with this harness that's here. So we're going to have to cut this open and disconnect the harness from the old battery pack that's no good. Okay, with the plastic shrink wrap off, I think you can see a little bit of the leakage in here. And what they've done is they've just tack welded these cells together. And on the positive end here, there's a thermistor. And the thermistor is attached to the white lead here. And then the green lead is attached to a, well actually that's the thermistor, is the green lead. The red lead, the white lead is going to a thermal cutout semiconductor, which is right there. And so all 3 are ganged together, the white and the reds, and they go to the positive lead, and then the thermistor and the 2 negatives are ganged together to go to the negative. So we're going to disconnect these right from the battery right here. And these are the ones that we're going to put on the new battery. And we're going to mimic the same pattern on this battery pack. So we're just going to pluck these off like that. And now we've got the harness that we need to put on the new battery pack. And we're going to put them just this way. So if you look here, I've already drawn this out. You can, to stagger your batteries, you can just trace the batteries onto a piece of paper, and you can see how we're going to gang them together. And then we're going to, at the other end, we're going to take the negative and the positive and put those out. Okay, so you've applied the glue gun in 3 seams on one side and 3 seams on the other side to glue them all together. This is the welded side that's been pre-welded by the factory. Just so you can keep track of them, I went ahead and put the polarity on them. So you can see here, as viewed from the top, the ones that are tied together are now in the correct positions. And you can see that from the lug side, they're in the correct positions now. Now this is going to go to your bus. There's going to be 3 leads. 2 of them are black ground leads. 1 of them is a green lead that goes to a thermistor and then goes to your bus. This one has 2 leads that are red that go to the positive, and then there's a white thermal cutout component that then goes to your connector. So you're going to reuse the connector and just solder them to the 2 leads here. These are going to have to chain together, the positive to the negative, so you can create a series. So you're just going to need to get your soldering gun out and just put a little bit of a link there and solder those together. And then we'll solder the and reuse the old harness that has the thermistor and the cutout switch. Those are expensive parts. They're about $11 and $7 respectively. Then you've got the connector itself, which you'll have to track down. So that's another $20 worth of parts. So you might as well reuse that, pull those off the old battery. Okay, so on this side, these have already been tack welded by the factory, and they've already been nicely covered with insulating paper. So that's actually nicer than the original ones that weren't coated at all. They were just shrink wrapped the way they were without any coating. Up here, I've temporarily pulled off where we're going to do our things. We have to do 3 solders to gang these together. And then this is your negative lead, this is your positive lead, and these, all the tabs have been folded against each other, so we'll just solder here, here, and here, and then we're going to solder the negative lead to here and the positive lead to here. Okay, with the solder connections made, we're going to rewrap the batteries. I didn't care for the thin plastic wrap. I just put it over the 2 components so they don't get any outside air, so they can get a good reading on the battery. But other than that, I just gave them a simple wrap, and it's ready to put back onto the circuit board for reassembly. Surprisingly, the old batteries were only 1650 milliamp hours, 1.6 amp hours. The new ones are 2.2 amp hours. So might be an improvement, hard to say. I guess we'll find out when we see how many cycles the battery has when we test it out.